Scientists and space fans are getting worried about Pluto maybe bumping into Neptune. Big names like Neil deGrasse Tyson and Michio Kaku are talking about what could happen. So how did Pluto get on a path that might cross Neptune's, and could this cause problems for us on Earth? Pluto used to be called a planet, but now it's a dwarf planet because of its weird path. Still, people find it cool. Some experts say Pluto and Neptune's paths are getting too close. They're even warning that they might crash, which could be bad news for Earth. Pluto takes about 248 Earth years to go around the Sun. Since we found it in 1930, it hasn't even made one full trip yet. What's interesting is that Pluto's path is like an oval, not a circle like the other planets. Plus, it's tilted at a steep angle compared to the main plane of the solar system. The thing is, Pluto's path crosses Neptune's. For about 20 years each orbit, Pluto gets closer to the Sun than Neptune does. So why haven't they crashed already? The answer is gravity from other planets. People started studying Pluto's path right after they saw it. It looks strange. Most planets, Pluto's path is tilted and stretched out. What's even weirder is that it crosses Neptune's. Even with all this, Pluto's path is pretty steady, which shows how gravity works in space. Imagine three things pulling on each other: Pluto, Neptune, and the Sun. It's like a complicated dance. Scientists say that a thing called asynchronous libration helps keep things balanced. This means that when Pluto crosses Neptune's path, they're always far enough apart to avoid hitting each other. Another thing, nodal vibration makes sure Pluto is either above or below Neptune's path when they get close. And a VZK oscillation makes Pluto's path look crazy. But it's actually pretty consistent. Back in the 80s, people ran simulations that showed Pluto's path is chaotic. Tiny changes can make a big difference over time. But those same simulations also showed Pluto's path stays steady for billions of years. New computer models are helping us see how big planets like Jupiter, Saturn, and Neptune mess with Pluto's path. Pluto and Neptune have a special connection. For every 2 trips Pluto makes, Neptune makes 3. This helps keep them apart. Jupiter's big gravity also helps keep things steady.
Saturn.
Not as much, but it helps too. Simulations say that all these planets working together keep Pluto's path safe and predictable. Without these things, the solar system would be a mess. Planets crashing or flying out of the system. Knowing about Pluto's path is important because people are wondering if it will crash into Neptune. It helps us understand how the solar system works. Pluto shows us that even paths that look unstable can be okay because of gravity. We need to keep watching and studying these things to learn more about space. Space is weird, and Pluto's path proves it. Orbital chaos means that a planet's path can change a lot depending on its speed and where it starts. Even tiny changes can make a big difference for Pluto. Computer models help us see this. By changing things in the simulations, we can see how small changes turn into big changes in Pluto's path. Studies from the 80s showed that even though things like asynchronous and nodal vibration help keep Pluto steady, its path can still be unpredictable. A small change in where Pluto starts or how fast it's going can send it on a totally different path over millions of years. But even so, Pluto's path stays surprisingly steady for billions of years. This means that even though it looks crazy, there's an order to it. When we try to guess what will happen with planets like Pluto, it's hard because things are unpredictable. Good models can help us guess, but we can't be sure. These models need exact information, and even a small mistake can change the guess. The chaotic nature of Pluto's path reminds us that the universe is always changing. We've learned a lot, but there's still so much we don't know. The distances between stars and planets are so big that crashes don't happen often, and planets without a star are rare. So, planets crashing into each other is very unlikely. Studying how giant planets affect Pluto's path helps us understand the solar system better. Each planet changes the others a little. Even with all these forces, some scientists still worry about Pluto and Neptune crashing. So why are people worried now? Neil deGrasse Tyson has some interesting thoughts about this. He's the one who said Pluto should be a dwarf planet, not a regular one. He says our understanding of how planets move is always getting better. To him, Pluto's change in status shows that we're learning and changing our minds about space. He thinks Pluto's crazy path shows us how much we still have to learn. He believes these unknown things make space so cool. Tyson also says that big space events get people interested in astronomy. He thinks things like Pluto's weird path and its change in status are chances to get people excited about space and learn more. By pointing out the crazy things about how planets move, Tyson hopes more people will appreciate space science. Tyson is still telling people that Pluto's unpredictable. Movement could be dangerous. After doing a lot of research, he's worried that the three-body problem might cause Pluto to crash into Neptune. He says this could mess up the solar system's gravity and cause problems for Earth. A crash like that would be huge. It would release a lot of energy and could break Pluto apart because it's small and icy. Pieces from the crash could spread around the solar system and be dangerous to other planets. For Neptune, the crash could even change its path or atmosphere. Michio Kaku, a theoretical physicist, also has some ideas about this. He connects the study of planets to big questions about physics. He sees Pluto's path as a way to plan future space trips. So understanding how Pluto and Neptune affect each other could help us travel through the outer solar system and avoid problems. Kaku also says that what we learn from Pluto can help us study other things in space. When talking about planets, Kaku often points out how orbits and theoretical physics are connected. He thinks the complicated gravity between Pluto and Neptune shows the basic rules of the universe. Kaku's work tries to explain these rules. He says that studying planets, especially crazy ones like Pluto, can teach us about how the universe is made. Like Tyson, Kaku has talked about what would happen if Pluto and Neptune crashed. He thinks it would be a big deal for astronomy and could help with string theory. String theory says that particles are tiny vibrating strings. A big crash in the outer solar system could create extreme gravity and energy, which would let us see how things act under those conditions. The gravitational waves from the crash could give us information to test string theory. Even though Earth probably wouldn't be physically affected, scientific results could be huge. It could help us understand basic forces in matter. Pluto's path shows how planets can be stable and chaotic. Its weird path, affected by the gravity of big planets like Neptune, shows how complex space is. The universe has many mysteries, and the three-body problem is just one. Scientists are thinking about other possible disasters. Even though planets crashing is unlikely, it's not impossible. The way planets' paths are changed by forces, especially gravity, is shown by the three-body problem. In crowded systems like TRAPPIST-1, which has 7 Earth-sized planets, gravity can create patterns in the planets' paths. These patterns can mess up the paths and cause crashes. TRAPPIST-1 is stable now, but scientists are watching it to see how planets interact when they're close together and under a lot of gravity. This helps us understand how planets' paths change over time. Rogue planets, which float through space without a star because they were kicked out of their systems, add another layer of unpredictability. These planets can travel far and might enter other star systems. If a rogue planet enters a new system, it could crash into one of the planets. But space is so empty that the chances of this are very low. Space is full of surprises, and Pluto's orbit is one of the biggest. The idea of orbital chaos shows how sensitive a planet's path is to its starting speed and location. Even tiny changes can totally change where it ends up. Computer models let scientists play around with these things and see how small tweaks can lead to big changes in orbit. Studies from the 80s turned up something cool. Even though things like asynchronous and nodal vibration help keep Pluto steady, orbit can still be unpredictable. A little nudge here or there, and it could be on a completely different course in a few million years. Even so, Pluto's path has been surprisingly consistent for billions of years. It means there's an order to it, even if it looks crazy. When you're trying to guess what planets with weird orbits like Pluto are going to do, it's tough. Those fancy models can give us an idea, but they also show us what we can't know for sure. They depend on getting the starting info exactly right and being able to copy complicated interactions. Even a small mistake can throw the whole prediction off, making it really hard to nail down. The crazy thing about orbits like Pluto's is that they remind us how things are always changing out there. We've learned a lot, but Pluto shows us how much more there is to discover. Luckily, with all the space between stars and planets, crashes are rare. And those planets that don't orbit a star are pretty rare compared to everything else. So a direct planet-to-planet collision is not something that happens a lot. Looking at how the big gas planets affect Pluto's orbit helps us see how everything works together in our solar system. The size and place of each planet has a slight effect on how the others move. Still, even with all of these gravitational interactions, some really smart scientists are still concerned about a possible Pluto-Neptune smash-up, so why are people getting worried now, even with all evidence that it's stable? Neil deGrasse Tyson, that well-known astrophysicist, has a few takes on the whole Pluto thing. Tyson, who famously supported Pluto's switch from full planet to dwarf planet, thinks our understanding of orbits is always getting better for him. It's not about kicking Pluto out of the planet club. It's about what we learn and adapt our understanding. Tyson sees Pluto's wild orbit as a sign of everything we still need to learn. All these unsolved questions make space worth checking out. Tyson also knows that big space stories get the public excited about astronomy. He sees things like Pluto's weird orbit and its planet downgrade as chances to get folks thinking about space and get them interested in the cosmos. By talking about the crazy parts of orbital physics, Tyson wants to get more people interested in space science. Tyson's still telling people to be careful about Pluto's unpredictable path. After a bunch of research, he said that three-body thing with Neptune could actually be dangerous, saying they're due for a collision. He thinks something like that could mess with the whole solar system and have bad effects all the way to Earth. A crash like that would be huge, releasing tons of energy. It might even break Pluto apart, since it's not that big and mostly ice. All that junk from the crash could spread around the solar system, maybe causing problems for other planets and moons. Neptune might even have its orbit or atmosphere changed, depending on how hard they hit. OKU. A famous theoretical physicist, known for his work in string theory and being friendly to the public, brings a smart perspective to the situation. Kaku connects the study of planet movement to bigger questions in physics. To him, Pluto's orbit is how to view space exploration, and thinks that learning how Pluto and Neptune affect each other with gravity is super important for planning space travel. With this understanding, we have a good idea how we will travel through the edges of the solar system. Kaku often highlights the connection between orbital mechanics and physics. He thinks that complex gravity things like planets dancing are just how laws of the universe work. Kaku's research, which is string theory, tries to explain why things happen. Especially orbits can show stuff about the structure of things in their natural structure with Pluto. Kaku is warned about some bad consequences from the potential crash. Theoretically, that event would be so great for astronomy and can further string theory, which visualizes particles and the universe's matter and forces. The gravitational event is rare to observe, and it will be the matter and forces under those circumstances. Especially in gravitational waves is the prediction of the string theory for space-time and space. Pluto is out of the way, and because how far it is, Earth would not be affected. It could push our understanding of the matter on Earth. Pluto's orbit shows the balance and chaos in our solar system. Neptune and its gravity are very important to note and highlight the natural way the solar system is created. However, the three-body problem is not the only possible disaster. Collisions is still a possibility. The way the planets move due to gravity is a very high highlight point and a critical area for planetary bodies. TRAPPIST-1 is a good example where planets can have orbital resonance where they can destabilize the orbits. But that isn't a thing because they are very closely being tracked due to gravity. And studying how those planets act is very important. Rogue planets is also very important. Where celestial bodies do planet mess up, these planets can bump into other systems, which can eventually bump into those systems as well. Eventually these planets can collide.